Maple Ridge Thunderbolt 4. We have a subscriber that's asked about an ASUS Thunderbolt 4 motherboard. Now I gather from what he said, number one, it's Thunderbolt 4. Number two, he has an ASUS motherboard. But number three, right now he's got apparently Thunderbolt 3 and he wants to go to Thunderbolt 4. So that means a new motherboard. So other things we know and what we're going to look at, I think the easiest way to start with this, because he asked what's the least expensive Thunderbolt 4 motherboard. So I want to show you a couple of motherboards because we need to look at the resource allocation on that board, because I'll tell you right now, once you put Thunderbolt 4 on there, that's it. So the first thing we need to do, and by the way, there's two ways to get Thunderbolt 4. Originally when we started, we advocated the ASUS ProArt B550, and that was having Thunderbolt 4 on AMD. Okay, that was built onto the motherboard. But now that everybody wants Thunderbolt 4, or those that want it to do everything, my suggestion and the best way to go with this is to have Thunderbolt 4 through the add-in card. So based on the criteria we've been given, and I won't show you the message because I can't find it, we've had so many of them, but it's been dancing in my head, and that's why we need to do this. Let's go look at the Thunderbolt 4 add-in card from ASUS, because remember, Thunderbolt 4 now is vendor specific on the implementation. So ASUS uses a 14-1 pin header. And I just found out the other day that even though MSI doesn't have an add-in card, the Thunderbolt 4 on their motherboard, that's a 16-1 pin header. So let's look at the card. We're going to go to the technical specs for the Thunderbolt 4 add-in card, and what we need to look at here specifically, compatible models, the ASUS Intel 500 series and later models with a 14-1 pin Thunderbolt header. I've taken the liberty of downloading the documentation for the Thunderbolt 4 add-in card compatible model list. Now what we're looking at specifically on the left, top left, is the Z590 chipset. The two chipsets on the right we're not going to get into based on feature set. And on the bottom, to reiterate, that's the AMD 550 chipset, of which, as we said, we advocated the ASUS ProArt B550. Okay, all these motherboards take the add-in card. Now what we're going to look at are two of these on the bottom of the list, the Prime Z590M Plus and possibly the Prime Z590-P. It'll depend on the orientation on the list. Next stop, we're going to go to the PCPartPicker System Builder Guide. First thing we'll do is we're going to choose a motherboard, and we're going to choose that motherboard based on two things. Number one, ASUS. Number two, we're going to look for the chipset, Intel Z590. And we're going to find 15 compatible products. Okay, up here on the top right, based on the other question, price, we're going to change orientation to price. And two motherboards are identified. One is microATX and one is ATX. Those two prices fluctuate around $150. And those are the ASUS Prime Z590 Plus and the ASUS Prime Z590-P. Let's take a look at the ASUS Prime Z590 Plus. I'm going to highlight that. We'll do a right click, search Google. Let's take a look at that motherboard. I want to go to technical specs. And number one, I'm going to take a look first at expansion slots and then next at storage. And then we're going to go download the manual. Okay, now here's where we want to pay particular close interest. Intel 11th and 10th generation processors. Number one, we have one PCI Express 4.0 by 16 slot. That is by 16 mechanically and electrically. Now, here's where we get into the nitty-gritty. With an 11th generation processor, we have PCI Express 4.0. However, with a 10th generation processor, we have PCI Express 3.0. Hold that thought, keep that in mind, because I'm going to come back and show you in just a minute how that relates to what we're looking for on the processor for PCI Express resource lane allocations. That's important. Okay, then the next set of resources we're looking at, through the chipset, we have one PCI Express 3.0 by 16 mechanically slot that is 4 lanes electrically. And then we have two PCI Express 3.0 by 1 slots. And it mentions PCI Express bandwidth bifurcation. Yeah, that's something else we're going to get to. Well, that's not going to work on here, but it's a feature there. Okay, let's go down now and take a look at storage, because this also involves PCI Express resources. We have 3 M.2 Nvme slots on an 11th generation processor. That's key. Number one, the primary M.2_1 slot, and then to reiterate, only on the 11th generation processor PCI Express 4. And then number 2 and 3. Under the chipset, M.2_2 and M.2_3. Those are both PCI Express 3.0. Now we need to go to support. I've taken the liberty of downloading the manual, and we're going to look at the specification summary. Actually, there's three pieces of information I like. One, the specification summary. Number two, I like to look at a diagram, which we don't have. And number three, I like to look at the motherboard layout. And actually, the motherboard layout is what I like to look at first, because I like to physically see what's what, who's on first, where things are at, and then compare that as we look at the summary chart. So looking at page 14 for the motherboard layout, what I want to see is physically, we have PCI Express bus 16_1, PCI Express bus 16_2. We have up here near the CMOS battery, M.2_1, M.2_2, and M.2_3. Yeah, that one right there is for the Wi-Fi. What we're looking at is M.2_2 and M.2_3. And then, of course, our PCI Express by 1_1 and PCI Express by 1_2. Those are both single lane slots. So this PCI Express by 16_1, to reiterate, is a 16 lane slot. And PCI Express by 16_2 is a 4 lane slot electrically. Now what gets tricky is how that slot and how that M.2 connector are allocated. For example, if we use the 8-core processor that gives us PCI Express 4, then we have access to that M.2 connector, and I'm going to show you those specs in a minute. However, if we use a higher core count processor that's PCI Express 3, we lose that connector. And I think it's kind of a bummer having to make those decisions and choices. So let's go look at the chipset, then let's look at the CPU, because the CPU, I don't know, based on the processor that the gentleman has, whether or not he's going to have to upgrade the processor. In other words, he's got a system, but he wants, number one, Thunderbolt 4. And number two, my expectation, because most people stick with the same brand of motherboard, it's going to stick with ASUS. And then number three, he's asked about the least expensive. This is one of two, because we still got another motherboard to look at. But let's first look at the chipset, then let's look at a processor that we'll need to pick, and I'll do that through PCPartPicker. Chipset. Now this is the Intel Z590 chipset, and what I want to look at is resource allocation. And we're looking at PCI Express 3.0, and we have 24 PCI Express lanes. Keep that in mind, hold that thought. Going back over to the PCPartPicker system builder, we have selected, number one, the motherboard, and we're going to do this same process again with a different motherboard. But let's go choose a processor, and we'll look at the difference in how some of this is going to work out. Okay, right here at the top where I'm going to select core count, I'm going to change the orientation by 10 cores, and then we'll come down and look at an 8-core processor. Now this part is very dependent upon what we talk about and how we build systems, as we have allocated resources for 4 different computer level builds. Number one, an entry level, which we call a 10-core. Number two, a secondary level, which we call 16-core. Then we go to a third, which would be a high-end desktop like we have here in front of us, which is the Gigabyte TRX40 Designaire. And then number 4 would be on the WRX80, where you have a workstation. Okay, based on a 10-core machine, that's PCI Express 3 on Intel. If we want PCI Express 4, we have to go with an 8-core machine. Let me show you how that plays out. For example, if we were looking at this particular processor, which is the Intel Core i9 10850K, gives us 10 cores, 3.6 gigahertz. It has video built in, and that processor is at that price right now. Okay, that would give us 10 CPU cores, to reiterate, and I say this because it's relevant that you're going to be hearing more about the Adobe multi-frame rendering, and that specifically is the Adobe After Effects multi-frame rendering CPU optimization formula. In fact, I just saw a press release from Boris Effects that says they now support that. That was due out back in May. This is now near the end of the year. We're looking in October. You're going to be hearing more about that formula. Okay, I mention that because that formula addresses 2 things. One, the CPU core count times 4 equals the RAM, and number 2, the CPU core count equals the video RAM. So 10 cores, 10 gigs of video. 16 cores, 16 gigs of video. And if you got 16 core CPU times 4, 64 gigs of RAM. Okay, all that is about processing power. It has nothing to do with storage capacity. So I want to throw that out there and mention that for those that information matters on. Because if we're talking about an entry-level machine, 10 cores, if you want PCI Express 4 on Intel with 8 cores because of the resource allocation. So let's keep going and go a little further. I just think it's important to point these little details out because, again, change one thing changes everything. Okay, 10th generation processor. Let's go to an 11th generation processor. We have to go to 8 cores. And we are looking at, and to get integrated graphics, we've got one option. That's an Intel i9 11900K, 8 cores, integrated graphics. We're going to add that to the list. And now we have 2 items on the list, motherboard and processor. Okay, I'm going to do the same thing with the processor we did with the motherboard. I'm going to click on the processor. I'm going to highlight that processor, right click, and I'm going to go search. And I want to verify what I have in that processor. And what I'm looking at, and I'm looking for, this says this will support DDR4 3200. Hold that thought, we'll come back to it. And right here is what we want. PCI Express 4.0, configurations, one 16-lane slot plus one 4-lane slot. Or I should say, one 16-lane resource and one 4-lane resource. That's crucial because we have 20 PCI Express lanes. Let me show you how that works. Looking again at the motherboard and the motherboard layout, if you want to utilize those 2 resources, you got to use an 8-core processor. Otherwise, if you use the 10-core processor, which is PCI Express 3, you lose that connector. And again, the Adobe After Effects Multi-Frame Rendering CPU Optimization Formula says nothing about storage. It's all about processing power. But these are your trade-offs when you're dealing with Intel. Now we need to go look at the Specification Summary. And DIMS said we could go up to DDR4 3200, so whatever you find in a package, I'd suggest getting whatever has the best value in RAM. Sometimes you'll find faster RAM will be less expensive RAM, and depending on how you want to get the package. Now, yes, as we look on down here, the processor talks about supporting DDR4 3200, and the 10th generation supports a slower RAM, but as I have stated before, and I'll state again, I would recommend DDR4 3200, or you might look at DDR4 3600. See whatever the sweet spot is on the price. But what we want to focus on is right here on these resources under expansion slots and then storage. We have one PCI Express 4.0 slot on the 11th generation processor. On the 10th generation processor, that's PCI Express 3.0. Now, by 16 means 16 lanes mechanically and electrically, and remember we have 20 lanes to work with, so 16 lanes are allocated to that slot as long as it's the 11th generation processor for PCI Express 4. And through the chipset, one PCI Express 3.0 by 16 slot mechanically, that electrically is 4 lanes. And then of course you have your 2 PCI Express 3.0 by 1 slots. And again, that issue about bandwidth bifurcation for RAID, yeah, no. I'll come back and address that in a minute. And looking at storage, to reiterate, we have 3 M.2 slots, and specifically on the Intel 11th generation processor, M.2_1 will be active and it'll be PCI Express 4. But if you use a 10th generation processor, that's disabled. And on the chipset, M.2_2 and M.2_3 are both through the chipset, and both are PCI Express 3.0. So now the next question that comes up that we have to answer that was not part of the original question but other people ask. Can I put a dual adapter on there? No. Can I put a quad adapter on there? No. You don't have the PCI Express resources. Once you put the primary question, which was about Thunderbolt 4 on that motherboard, that's it. Okay, now hold that thought, because now I want to show you another motherboard and how the resources play out based on this question. I think it's good to compare. Now the first motherboard we looked at, and that's microATX. Let's take a look at this second motherboard, which is the ASUS Prime Z590-P. We'll highlight, right click, do a search. Let's go find that motherboard and let's look at the tech specs. And we want to scroll down to expansion slots, one PCI Express 4.0 by 16 slot mechanically and electrically, 11th and 10th generation processor, and with an 11th generation processor, PCI Express 4.0 by 16, with a 10th generation processor, PCI Express 3.0 by 16. Okay, with the 11th generation processor, we have 20 PCI Express lanes. With the 10th generation processor, we have 16 PCI Express lanes, and that's to the CPU. And through the chipset, one PCI Express 3.0 by 16 slot mechanically, that electrically is 4 lanes wide, which is what we'll need for the Thunderbolt 4 add-in card. And then of course the 2 PCI Express 3.0 by 1 slots. And then of course talking about bifurcation again, I'll come back to that. So same thing, let's go to support. We want to download the manual, RAID configuration, BIOS manual, we want the user manual. We'll take a quick look at the product specification summary. Memory again can be overclocked. It'll take up to 128 gigs. And I would go for the DDR4 3200, but any of these others again, like DDR4 3600, check and see what you get the best bang for your buck on speed. And the 11th generation processor can go to DDR4 3200, and the 10th generation, it says 2933, but I wouldn't buy anything less than DDR4 3200. You start trying to look for some of these, you're going to be hard pressed to find. You'll end up with something like 2666, and you'll end up paying more for slower memory, so I'd get the faster RAM. Okay, the expansion slots. For the 11th and 10th generation processor, one PCI Express 4.0 slot for the 11th generation, and it's PCI Express 3.0 for the 10th generation. And on the 11th generation, again, this says PCI Express 4.0 by 16, correct. And on the 10th generation processor, PCI Express 3.0 by 16, correct. But remember, on the 11th generation processor, we have 20 PCI Express lanes, whereas on the 10th generation processor, even though it's PCI Express 3, there's only 16 lanes. So hold that thought. And on the chipset, through the chipset, one PCI Express 3.0 by 16 slot mechanically. Electrically, it's 4 lanes wide, which is what we need. That's adequate for the PCI Express 3.0 Maple Ridge add-in card from ASUS. And then, of course, the other two PCI Express 3.0 by 1 slots. And that bandwidth bifurcation, I'll address that again in a minute. Now let's look at our storage. We have 3 M.2 slots. And on the Intel 11th generation processor, because we have 20 lanes, which is the first 16 lanes to that first primary PCI Express by 16 slot, that leaves the other 4 lanes, PCI Express lanes, to go to the M.2_1 slot. And that's only on the Intel 11th generation processor, PCI Express 4. Okay, other processors, that slot's disabled. Good to know. And again, through the chipset, M.2_2 and M.2_3, PCI Express 3.0, 4 lanes each. So there's your bottleneck. And let's take a look real quick on the motherboard layout. I always like to physically inspect the motherboard and see what's what. PCI Express was 16_1, 16 lanes on the 11th generation processor, PCI Express 4.0, and because 16 lanes are allocated to that slot, we also have 4 lanes that can be allocated to that M.2 Nvme connector, which is M.2_1. However, 8 cores. If you go to 10 cores, you lose that M.21 connector, which is kind of a bummer. And then to reiterate through the chipset, M.2_2 and M.2_3. And those are through the chipset. And PCI Express was 16_2, which is a 16-lane slot mechanically, is only a 4-lane slot electrically. And I need to also point out while we're at it, right here, Thunderbolt header, right there on the bottom, 14-1 pin. So one final thought, can I add a either one of these, which is going to be the same answer. Can I add a dual M.2 Nvme adapter? No. Even if you didn't put Thunderbolt 4 on the motherboard and Thunderbolt 4 is the primary requirement, no. And can I put a quad adapter on here? No. Same reason. You don't have enough resources. It's a tough call. It's a hard sell. And those of you that are building an Intel machine, I can't believe you put up with some of this stuff. It just it floors me. I enjoy looking at this, and I enjoy talking about this and explaining this. But I have to come back to the Gigabyte TRX40 Designaire. Whatever you choose on a TRX40 high-end desktop, where you have, with this example, 2 16-lane slots and 2 8-lane slots, these are dedicated resources. And I have 4 M.2 connectors. I have the primary 1 and 2 that are directly to the CPU, but they're not shared resources. And then I have 3 and 4 through one heatsink that are through the chipset. But even through the chipset, they're still all PCI Express 4.0. The only PCI Express 3.0 thing we've got in here is in the second 8-lane slot, which is the Gigabyte Titan Ridge Thunderbolt 3 card. It takes 4 lanes, and the other 4 lanes in this slot we lose. But those are still dedicated resources. Now, things are coming around, and I always say change one thing changes everything. The information has now become available that we can start talking about the Intel Z690 that everybody's so giddy about. And I think it may be an eye-opener for some others as we compare to what we talk about here. So, and now the big what if. The big what if being, what if I don't use a GPU? Okay, we've already identified two different CPUs, 10th generation, 11th generation. We've talked about the cores, and they both have video on the CPU. And if you're going to build a machine like we have here, where we talk about processing power, because for content creation, it's about CPU and GPU. However, if you decide not to put a GPU in there, all bets are off. The answer is still no. Bifurcation, that's the reason why. And not just the bifurcation they show that we've seen in the motherboard manuals, but full bifurcation, 4 by 4 by 4 by 4, not 8 by 8, not 8 by 4 by 4, but 4 by 4 by 4 by 4. Because if you put a quad adapter, which handles 4 M.2 Nvme drives on one 16-lane slot mechanically and electrically, it has to have full bifurcation so that each one of those 4 drives are seen 4 by 4 by 4 by 4, because each drive requires 4 PCI Express lanes. So even if you don't use a GPU, you still can't use a quad adapter, and I wouldn't even bother trying with a dual adapter. Not going to happen. So I hope that helps. I want to thank you guys for watching. My name is Gil Boyd. This is BuildOrBuy. We're on to the next video. We're out.